Okay, this is a lecture video for college algebra, sections 2.4a and 2.4b. And in this section, we're going to be looking at various methods for solving quadratic equations, which are second degree equations. Specifically, we're going to be looking at the methods of factoring, using the square root property, the quadratic formula, completing the square, all as methods to solve second degree equations, which is quadratic equations. Then in the end of this section, we're going to be looking at rational equations, and those are equations that have expressions in the denominator that contain variables. So when we do those kind of problems, we're going to be clearing the fractions, and thus it's going to result in a quadratic equation, which we will then go to the methods that we've already gone over, factoring, square root property, see which one applies, and solve the problem to its end. Okay, we're going to start with the method of factoring, and I have an example up above here. I've just listed all the steps that I'm going to use for each method, so you can go back to them if you need to, but I'm going to be verbalizing these steps as I go along and in more detail. Okay, so this is a quadratic trinomial because there are three terms and the highest degree is 2. That makes it a quadratic equation, that one term right there. So when you're going to solve these quadratic trinomials, you need to zero them out first. Zero out one side of the equation, which would simply take you moving the 7x to the left, at which point it would become negative 7x. So nothing is there anymore on the right-hand side, so you've zeroed it out. And then you're going to list these terms in descending order. Highest degree, next highest degree, and the constant. Okay, I want to point out to you, remind you of the names of the coefficients. This coefficient is called A. This coefficient is called B, and it includes the sign in front of the number. And this coefficient is called C. You're going to need to know the names of these values because I'm going to refer to A, B, and C as I demonstrate the various methods for solving quadratic equations. So we are looking to solve the next 3 or 4 examples by factoring. Parts A, B, C, and D, I believe, are all under this factoring directions. And so I'm going to point out to you when a specific factoring method works in the problem. Okay, so when you have a trinomial that is second degree and the A value is 1, you're going to use the factoring method called guess and check. And I'll demonstrate what you're guessing and checking. Okay, this method starts like this. Step 1, you're going to be looking for two numbers that multiply together to give you the C value, which in this case is 10. And in step 2, we want to be able to sum the two numbers together that you just used in step 1, but to get the B value, which in this case is negative 7. Okay, and you want to make sure that you're getting the signs right in everything. You're looking to multiply two numbers to get a positive 10. The only way you can multiply two numbers and get a positive is if they both have the same sign. That leaves us with the choices of either a positive times a positive or a negative times a negative. But being that I want to add these two numbers and get a negative, I'm going to go with both numbers being negative. I know that 2 times 5, 2 and 5 can be combined to give me a 7. So I'm going to use 2 with a negative and 5 with a negative. These multiplied together give you positive 10, whereas when you add them, okay, adding two numbers that have the same sign, you add these up, you get a 7, and it keeps that common sign. So not only have I made this work, this also works with the two numbers that I've come up with. Okay, so you're just going to start off by naming numbers that you know from your times tables will multiply to give you this. Make sure you're getting the right sign, and you're going to use this to guide you. Step 2. So you're kind of working those two steps simultaneously. Once you find this pair of numbers using these two steps, the trinomial is essentially factored at that point. So I'm going to move up here where I have some room, go into my factoring shell, my two parentheses, which is always going to be you're going to be using when you factor a quadratic trinomial. And then the front, you're asking what times what gives me that first term of the trinomial, and which is an x squared. So what times what? X times x. So you're splitting that x squared into x times x. Then what you fill out the back of each parenthesis with is these numbers you found. -2 and -5. And it doesn't matter which one you list first. Once you get two factors, this is considered a factor, this is considered a factor. A factor can have two terms, one terms, however many terms. So both of these are factors. I just don't want you to think that they have to have two terms in them and be in a parenthesis just to be a factor. Factors are things that multiply together to give you a number. So we're saying that these two factors multiply together to give us 0. And the zero factor property says that when two expressions multiply together, two numbers multiply together to give you a 0, one or the other, or potentially both, have to be equal to 0, or else you couldn't get this from a product. That property allows you to set each factor equal to 0. So you're actually saying either this could have been equal to 0 or this could have been equal to 0 in order for you to have a product of 0. When you solve these little equations, you're simply bringing the number to the opposite side, thus changing its sign. So -2 becomes positive 2 when it moves to the other side. So x equal to, the 2 is now over here on the right. You've isolated x, and that is one of the solutions. Same thing here. You're going to move that -5 to the other side. So this -5 is not here. It's on the other side, acting as a +5, and thus you have isolated the x value. So x equal to 5 is your second solution. Okay, so those are the first two solutions. Okay, we're going to move on, continuing with the factoring, but get to some more elevated factoring methods. So now we get to this next problem. Once again, we have a trinomial, a second degree term, a first degree term, and a constant. And again, you're going to zero it out. So you're going to bring this 4 to the opposite side, and that will give you 2x squared plus 7x minus 4 equal to 0. Okay, now in this problem, notice that the a value is no longer negative. Again, this is a, this is b, +7, and this is the c value. So when you see that your quadratic trinomial is bigger than 1, then you're going to go into a method called split the middle term. Okay, so I'm going to demonstrate how to do that. Split the middle term. Okay, so now this method begins with step 1. I'm going to do it over here. This is step 1, and let's come all the way up here. We're going to need all the room we can get for this problem. Move this down. Okay, so step 1, again, you're going to be working with number combinations. This first step is going to start slightly different than the first step that we used in the previous problem. Again, yes, you'll be looking for a product, but this time instead of it just being equal to the c value, you must incorporate the 2 as well. So you have to multiply these two first, just like I'm stating right here. Multiply a times c, and that's the number you're shooting for with this product that you're going to create. Step 2, which you will work simultaneously with step 1, just like the second step of the previous problem. You're looking for the two numbers that you used up here to get to product and get -8. You want the sum of them to be equal to the b value. So that second step doesn't change. And your b value is 7. Okay, so now you taking into consideration the signs that you're going for here, if you're going to multiply two numbers to get a negative, any kind of a negative, one or the other needs to be negative. How do you know which one to make negative and which one to make positive? Well, first I'm thinking 8 and 1. 8 times 1 is 8. Waiting to see which one I should give the negative, and all you have to do is look at the second step to make that decision. If you're going to add two numbers, knowing that one of them is negative, and you're going to add a positive and a negative, but you want the answer to come out positive, then the bigger number must be positive. So we're going to let this be the positive and this be the negative. And then both steps will work. So that the ruling sign is dictated by the bigger number. So 8 combined with negative 1 is 7, while 8 times negative 1 is negative 8. Once you have found the two values that satisfy this as well as that, that is when you're going to go into splitting the middle term. And the middle term is the linear term. That's this term right here. So when I say split the middle term, you're going to split it up using these numbers, but with x's pasted to them. So essentially, you're just looking for another way to write positive 7x. Copy the first term as is, as well as the back term. So here we go. And then instead of the 7x, we're going to use these numbers to rewrite that same 7x term. We're going to say positive 8x minus 1x. So you're just pasting an x onto each of these numbers, and that represents the 7x that was written in the original problem. You still have 7x in the middle. Okay, don't forget that last term, the negative 4. You have now taken a trinomial, 3 terms, and stretched it out into 4. And 4 terms, when you're trying to factor, lends itself to factor by grouping. And if you have forgotten those steps, you group the first two together and ask yourself, what do they have in common as a common factor? And that would be 2x. 2 goes into both of these coefficients, and they both have at least 1x. So this is what they have in common. You always put a single parenthesis next to any common factor that you take out, and you use that common factor as a multiplier to get these terms back again. So in other words, you're asking 2x times what would give me that term back again, and it would be an x. 2x times what would give me that term back again, and it would be a 4. And you can check it. 2x times x, 2x squared. 2x times 4, positive 8x. Okay, now leave the first two terms alone. Don't look at those any longer, and come to the back two. Concentrate on just these two terms and ask yourself, what do these two terms have in common? And that would be nothing more than a negative 1. So I'm going to pull that out as my second GCF, the GCF for the back two terms. Always a single parenthesis next to your GCF that you've just taken out. And again, just like I did here, use this GCF as a multiplier to get that back again as well as that. So negative 1 times x is negative x. Negative 1 times positive 4 is negative 4. So at this point, if you're going to successfully complete this factoring by grouping, you should have a binomial that matches a binomial in this term, because this is all considered one term at this point. Everything in front of this minus sign, and everything after the minus sign is the second term. Notice that both of these terms have x plus 4 in common. So once again, for a third time, here you go, pulling out a GCF. This was the GCF for just the front two terms. This was the GCF for the back two terms. Now I'm picking a GCF for these two terms. And what they have in common is x plus 4. So this is our third GCF. That is now what's common to the front term as well as the back term. And then what goes in the second parenthesis are those first two GCFs that you took out, the 2x and the minus 1. Don't forget to pull down that equal sign and the 0. You are then going to get solutions for these. Again, using the 0 factor property. You have two factors, x plus 4 and 2x minus 1. Again, factors are things that when multiplied together give you a certain result. So since the result of multiplying these two things is 0, that means either x plus 4 could have been 0 or 2x minus 1 could have been 0. Okay, I'm going to bring it up here to finish the problem, because otherwise I'm going to run into these problems that come down here. Okay, so for this x plus 4 equation, all you would have to do, one step, is move this 4 to the other side, thus making it a negative 4. This would be gone, and so the x is isolated, just like you want it to be when you're solving, and you have your first solution. Then we're going to use the other factor, which is 2x minus 1, and also set that equal to 0, using the zero factor property. This would take 2 steps to solve. You'd have to move the negative 1 as your first move, and thus it becomes positive 1, leaving the 2x here. And then you're going to divide by 2 on both sides to knock off that multiplier, which is the coefficient. You're going to remove it by dividing. So here you've gotten the 2 to go away, thus isolating the x. And your answer for 2x minus 1 equal to 0, your solution is x equal to 1/2. Okay, so there's your 2 solutions. Once again, getting 2 solutions because this is second degree. Next, notice that there's a difference in this equation compared to parts A and B. Both of parts A and B had 3 terms. Now all of a sudden, there's no constant. So when there is no constant, all you're going to use to get this thing factored is just take out the GCF. Okay, so let me separate the work for this problem. When you're splitting the middle term, because that a value is greater than 1, you have a few steps, and I'm trying to, just play them out for you very thoroughly. So for this one, the constant is missing, and that's when you're going to use a factoring method where all you do, you're not using guess and check, you're not using split the middle term, because this is more simplistic because it's missing the constant. All you do is look at what do these 2 terms have in common. Again, it has to be zeroed out. Anytime you factored, you better have a 0 on one side before you start doing whatever factoring method you're going to use. So all these have in common is an x. Always put a single parenthesis next to your GCF. I brought down the equal sign and the 0, so this is a GCF. And I'm asking myself, hey, what do I multiply that x by to get back each of these terms? So x times what gives me 7x squared? That would be 7x. X times what gives me negative 5x? That would be negative 5. And thus it is factored. This is one of the factors. It just happens to be a factor with a single term. And this is a factor, and this is a factor with 2 terms. So don't discount that factor that you've pulled out. Anything that has a variable is going to be part of a factor that you set equal to 0 to get the 2 equations. Okay, so as I finish this, I'm going to erase this just for a little bit more room. I'm going to set this factor equal to 0, and there you go. That's a built-in solution. It's already isolated for x, so there's nothing you need to do to get the x alone. So that's one of your solutions. Then the other one is going to come from this 7x minus 5 equal to 0. That would be 2 steps to get the solution. For one thing, moving the 5. So this will be gone, leaving you with, I'm going to have to come down here, leaving you with 7x on the left side and a positive 5 on the right side, because when it moves from here to here, it becomes positive 5. You're then going to divide that coefficient right off of the x in order to isolate it, and thus your final answer, your second solution. You already have 1, x is equal to 0. 0 is a legitimate number, so don't throw that away just because it came from a single factor with a single term. So I'm going to write this a little bit bigger. And this is your second solution. Okay, part D. That belongs to the set of problems that we're solving by factoring. This is also going to be split the middle term because just like part B, it has three terms and the A coefficient is greater than 1. So once again, this is going to be split the middle term. I'm going to leave this alone because I've already demonstrated one with this particular factoring method, and this factoring method is going to come up again later in the section. So we can wait till we get to one of those problems to demonstrate it yet again. Okay, so let's move on. This time we are going to use a different technique for solving these quadratic equations. You're going to notice that the majority of the time when you're using this property called the square root property, you're ultimately trying to get the square term all by itself with no multiplier. You're going to have to strip that off in the process and nothing added or subtracted from it. Okay, you're going to try and isolate the x squared term. That's what you're going for here. I want you to notice that one of your things that I'm hoping that you notice so that you know when to jump into this method is that there's no x term in these problems. Notice that there's no x to the first degree. So there's only two terms, a squared term and a constant, because you can move this over here and it's just one constant. You can move this over here and it's a constant. So you're going to be isolating x squared in order to solve it, but to recognize that you can even use this method, try to notice that the x term is missing. This over here, so I have some room to solve. Okay, so that x term is missing. And that allows you to use this square root property. Okay, so we're going to try and do this as our general solving technique. Isolate the x squared, then I'll go into the finishing details. So when you're going to isolate the x squared, never try to tackle that multiplier first. It's always get rid of whatever's added or subtracted first. So we're going to bring this over here. It becomes a negative 5. You then have 53 minus 5 is 48. This is gone, therefore all you have left is 3x squared. You still have not isolated the x squared. You just want a plain, clean x squared with a 1 in front of it. So this multiplier, you're going to get rid of it by doing division. Likewise on the other side. Okay, so now the 3's would be gone, and 48 divided by 3, just give a cleaner, simpler form of that, and that would be 16. Use your calculator for any help that you need with 48 divided by 3. I'm going to finish it up here and use all available space on this outline. Okay, I have an x squared on the left-hand side, and I have a 16 on the right-hand side. So now we go into getting rid of the square. So you have to understand, just like the opposite operation of positive 5, which is what makes it move over here, is that this arrow really means you're subtracting 5, subtracting 5. On this side, it makes it disappear. On this side, it combines with the number that's already there. So just like addition has an opposite sign, so there's an opposite, or what we really call an inverse operation for squaring. The opposite operation of squaring, the inverse operation, is to take a square root. That will get rid of squares. Whatever you do on one side, you must do on the other side, but on the side that is just purely numbers, you have to report both the positive and negative roots so that you're getting two solutions. Okay, this power dictates how many solutions. It tells you how many solutions you should be getting. Okay, so move this over a little bit so you can see it better. Okay, so we're going to report the positive and the negative root. So the square root on this side, all it does is get rid of the square, and out comes the x. Then over here, it is plus or minus 4. So all of these are going to be a demonstration, as well as part D on the next page. Demonstration of how to use the square root property. Only the solutions are going to come out slightly different looking. So these came out to be integers. If you want to list these two solutions separately, just state one of the answers, then state the other one, separated by a comma, just as My Open Math often asks you for the solutions when there's more than one solution. We're going to do the same thing here. We're going to go after, our main plan is to isolate the x squared, and then eventually we will take a square root on each side. That's how you ultimately make the square go away. Okay, but before you can take the square root of each side, you need to isolate the squared term. So we're going to always move anything that's added or subtracted to the squared term. If I move this over here, it becomes a negative 180. And that one move right there is what's going to cause your answers to come out slightly different than what you got here. You got integers here. Those are real numbers. Here we're going to get imaginary numbers, because you're going to see last step is to take a square root, but the number is going to be negative, which is going to cause us to get imaginary solutions. Okay, so this is gone. All you have is 5x squared, whereas over here you have a negative 180. X squared is still not by itself, so you have to get it by itself before you can make the square go away by taking a square root. Divide both sides by 5. Now you have a nice clean x squared. And what you have on this side, 5 goes into this 36 times with a negative in front of it. Okay, I'm going to move this right up here alongside my steps that I've done so far. And continue. Bring the whole thing up here so I can show you what I'm doing to each side. Okay, so we're going to make the square go away with this operation. Therefore, you have to repeat that operation on the other side. Report both the positive and negative version of that root. So that makes that go away. Out comes the x. You're reporting both the positive and negative root. And the square root of this is, you got to take the square root of the 36, that's 6. And you also got to take a square root of the number it is multiplied by, negative 1. Negative 36 is the same thing as 36 times negative 1. When you have a negative 1 underneath a square root, that is defined as I. Okay, so if you want to list them separately, it's negative 6i and also positive 6i, giving you two solutions. And you got to be careful with the directions for these type of problems. If they ask you only give real solutions, then you're going to have to, you pick a choice that says there are no real solutions. If they say give all solutions, that means you can give imaginary as well as real. Okay, now I didn't state here, but they will state in My Open Math. Okay, likewise, we're going to do this. Same main general idea. The technique for solving is the square root property. That takes you isolating the squared term, then taking the square root of each side. This will come out slightly different also. This one, the answers came out integers. This one, the answers came out imaginary numbers. And here, we're going to practice the concept of taking a partial square root at the end. There's a lot of problems involve that in this course. So we're going to move the 15 to the other side, which is the same thing as subtracting 15, because it's the opposite of that, and subtracting 15 there. I just show it with the arrow. So then you're left with 5x squared. 240, take away 15. You can use your calculator to help you with that if you'd like. It's 225. Okay, then don't forget, I need a nice clean x squared before I can go into that square root step. Okay, and that is what I have right now, x squared. And 225 divided by 5 is 45. So that's where I'm at right now. And now I can go and take the square root. Now that there's nothing added to the x squared or multiplied out here, then you go in, take the square root, take the square root here as well, and report both the positive and the negative root. So So out comes a clean x because the square root gets rid of that squared. So out comes just x to the first degree. Here I'm reporting both the positive and negative root, but you're going to be practicing the concept of how to take a partial root, where part of this comes out because you're able to take the square root of it and the other part stays in. The parts I'm talking about are the factors. So to make the least amount of work to finish this problem, I'm going to have to always suggest to you that you know what numbers have a square root. What numbers are perfect squares? In other words, they come from squaring some number. That's how they're achieved. Because if they come from squaring something, then you're able to take a square root. Here are numbers that come from something squared. This is 2 squared. This is 3 squared. This is 4 squared. This is 5 squared. This is 6 squared, and so on. You can go as long as you want. You are going to try to use, not try, do it. Use something from this list to break down your 45. You don't want to use just any number. I mean, the technique when you have no algebra behind you is that they tell you to break it down into prime numbers. Just keep breaking it down and then look for 2 of a kind. But that's a lot more breaking down, more steps. This will shorten it because you're going to use this times what gives you 45. You want one of these numbers, because if you're taking a partial square root, only one of them can belong to this square root list. And you want the biggest one you can find on this list so that you'll only have to break it down once. Okay, so you are able, these 2 numbers are still underneath the radical representing the 45. You can take the square root of this. It comes out as a 3. So the 3 has come out from underneath the radical while the 5 stays inside. Okay, so one set of answers came out integers, one came out imaginary numbers, and one comes out a partial square root. If you want to list them separately, your answers would be -3 square roots of 5. They don't care which one you get first, I believe. And +3 square roots of 5. Okay, moving to the next page. I'm going to stop after part D and then do the other 2 methods called completing the square, and then I'll attack the solving the rational equations on the last page, and I'll do that in the second video. Let's just finish up part D for completing the square. Now, I know that you do see an x to the first degree here, but because of that it's part of a binomial and that entire expression is squared, you're going to use the same steps, isolating the squared term. This is considered what's being squared. This is the squared term. You don't want it to have a multiplier. You don't want anything added or subtracted out here from it. So all we have to do is wipe out that 3, dividing it right off, and we will have x plus 5 squared, because these 3's are gone. And then over here, we're going to have 54 divided by 3, and that is 18. So in this problem, you get a binomial that you're looking at rather than just an x squared, and we're going to practice taking a partial root again. Okay, once you get to this step, let me bring it up here where I have more room. Slide this down. Just going to copy it again so I have room to work on it. So it's x plus 5 squared. And then over here, you have the 18. Okay, so this is considered like a single term squared. You jump right in there, take the square root of it, and that's going to erase that square, and out comes the base, this binomial. You can drop the parentheses at that point once the square is gone. And then don't forget you're also going to take a square root here, but report the positive and the negative root. So once again, from the list of things that you can take the square root of, 9 is what I'm going to use from that list to break this down. It is the biggest thing in that list that I was starting for you on the previous page that goes into 18. So this you'll actually be able to take the square root of, so it's going to come out as a 3. But I'm going to put that plus or minus in front of anything that's coming out from underneath the radical, while this 2 is going to stay trapped inside the square root symbol because there is no square root for that number. Okay, then you're going to give your final answer by isolating x. Before you can call it a solution, you must have the x completely by itself. So this 5 is going to come over here, thus acting as a negative 5. Typical way to give these answers is the integer portion first. This is considered the standard form of an answer like this. And then the radical portion of the answer. And you can list these separately also. If you wanted to do that, you could list this one using the positive sign in front of the 3 square roots of 2. You'll put a comma and then list the other one. Negative 5, and this time picking up the negative sign with the 3 square roots of 2. Okay, I'm going to cut the video off at this point, and in the next video I will do the remainder of this section.